In today's lesson, we're going to talk about something that we've been talking about all year long, the H, the horizontal shift. So if we quickly look back at a few examples from earlier in the year, we can see the theme, the trends that continue, and we'll see the exact same thing happens today when we talk about sine and cosine graphs. So here's a graph, or here's an equation, y equals x minus 2 squared, and we recognize that's a quadratic, so we can start with a quick sketch of the quadratic form, the parent function of a quadratic. And remember that this minus 2, that x minus h, is a horizontal shift. It just moves the graph over 2 units. And that is all. We saw it with the absolute value of x plus 3, that horizontal shift, because remember that's supposed to be x minus h. If we see x plus 3, that's a shift backwards 3. And we saw it with square root graphs also. All of this is exactly the same as what we've seen all year. And the good news is it's the same for sine and cosine too. The only slight difference with sine and cosine is it has a different name. I still like to call it the H, but it's also called the phase shift. It's what we used to call the horizontal shift. Now we're calling it a phase shift. The reason for that, when we talk the word phase shift, is what we'll call it with a periodic function, when it kind of repeats itself over and over and over again. We're just kind of moving the starting point over a little bit. You'll see what I mean in a second. So here's a graph, nice and simple. Y equals the sine of theta plus 45 degrees. We're going to do the same analysis of this that we do for all of our sine and cosine graphs. We'll start with the amplitude and the midline to get the range, and then we'll identify the period, and now we're adding in the new phase shift. Well, this one, everything is pretty simple until the phase shift. The amplitude is just 1, because the coefficient in front of the sine is 1. The midline is y equals 0, because there is no k there. K is 0. And so the range goes from -1 to 1. And since the b is also 1, that means the period is regular old 2 pi, although notice how they showed us we're talking about degrees here. So when that's the case, then you can use degrees for your periods also. And then the phase shift is the same h, the same horizontal shift we've seen all year, because that's plus 45 degrees in that parentheses. That means the phase shift is negative, or backwards, 45 degrees. And we can see how the graph looks. If the range is from -1 to 1, then that's how I will label my min and my max. Again, as before, I do want to see these very light little dotted lines here on the max and the min. I would put it on the midline here, except the midline is already the x-axis, so drawing the gray line wouldn't really help much because you can't really see it. For labeling the x-axis, remember the idea we've seen. You count 1, 2, 3, 4 even spaces, and at the end of 4 even spaces is the end of the first cycle, so that's whatever our period is, we'll put there. Of course, there was no horizontal squeeze or compression here, so the period is a regular 360 degrees. We can cut it in half again, so that each one of our quadrants is 90 degrees. Everything here is, so far, just the parent function of sine. And we know sine starts at the midline, goes to the max, back down to the midline, down to the minimum, back to the midline. And here's where the phase shift comes in. Notice how everything I've done so far is the exact same. It's the very, very last thing before connecting the dots is where the phase shift comes in. Every single one of those dots needs to be moved backwards 45 degrees. This is why labeling the x-axis is important. I know that each quadrant is 90 degrees, so 45 degrees will be exactly half of a quadrant. So every single one of these points will be moved backwards exactly half a quadrant. And you don't have to label the numbers on the x-axis. We just now have to connect our new dots. So I'll do that in a final color. Just a little bit at the end there. And there is our sine curve with the phase shift. So you can see how a normal sine curve, we expected it to start at the midline and go up from there. But with the phase shift, we started a little bit backwards.